With 4 million sounds, what will you create? Take the free trial today.
Hello to another video for the Superbooth at Home edition, or Home edition even. We're here talking to David with IK Multimedia. David is, where are you, David?
We are in Modena, in Italy.
Okay. So hopefully the summer sun and the spring is coming your way, right?
Yeah, we hope so.
Well, all the best to you all. So what are we looking at? You've got a new version of Arc, which is the room correction software, right?
Right. This is the version 3 that we just released last week. And it's a quite popular application since the first version was released in 2007. And back at the time, it was a quite pioneering kind of application because it was unusual to load a plugin on the master bus of your DAW to correct the listening environment. And by now, it's a quite common kind of application. And we think this version, that is version 3, improves the system considerably, especially in terms of quality.
Well, because you've been doing a lot of stuff with DSP and room correction with your speakers as well. You've got a lot of that technology sort of embodied in hardware. So has there been some cross kind of intuition technology from that?
Yes, I think exactly, Nick. I think that it's very unique to be able to see both sides of the stuff because we are also making studio monitors. And so first of all, we had to see very, very in detail how the studio monitors typically interacts with the room. And plus, in addition to that, we have a lot of experience, a lot of technology from the measurements of the speakers and cabinets and spaces, as you have seen from, for example, from our last release with the reverb from the sound. Yes, so from the Sunset Sound Studios. So analyzing speakers and analyzing room, putting all these technologies together gives the perfect match of the technologies that you need to correct a listening environment in a control room. So
what's different between version 2 and version 3? What's the kind of new stuff, I suppose?
Yeah, the most important difference, I would say, is the way the room gets measured. Because when you are going to correct a speaker in a room, you are relying completely on the measurements that you do. So we found out that the single plane that was used before to get the measurements in a room was not enough. So we used our VRM technology, that is the same that you use for measuring all the kind of speakers you find in Amplitude. We used it for the Leslie, we used it for the Sunset Sound. It's actually analyzing the room on a 3D space. So instead of moving the microphone on a single plane, we are now taking 3 different planes in front of the speakers. And this helps us a lot in identifying what issues are important to be taken out from the equation, and instead what are the aspects of the room that is better to leave there. Because the main focus of this upgrade, apart from usability that has been improved a lot, we will see this later on, is the sound. We wanted the correction to sound transparent. We didn't want the result to sound like a corrected room. Instead, what we wanted was that the system was sounding like a good room that has never been corrected.
Okay. That's a noble effort. I mean, that must be quite difficult. So how heavy is that on DSP? I mean, that must introduce some latency, presumably, into the monitoring path.
The big impact on the calculation is actually done on the measurement phase, and then once the filter is synthesized, it's not very heavy on the CPU, because the big part is done once for all after the measurement.
Right.
So runtime is not that heavy.
So there are 2 components to this. You have the measurement, which I think we got a picture of the mic here. So you got your specific mic, and I suppose by providing your own mic. Yeah. You've got that there as well. Then you can guarantee what the frequency response is going to be. So that's what you get when you buy Arc, from the get go, right?
that's very important because, as with any measurement system, you need to know the source perfectly. So when you use this microphone, the system is calibrated within plus and minus alpha dB. So it's a very good precision. Because this is a MEMS microphone, that means that it's not a superlinear element, but it's always the same, which is very important. Because this way we can have the fingerprint of the response in the software, we know it, and so we bring it to a very good level of precision. Actually, R3 can also work with the older microphones that we were selling with ARC before version 2.5. They were metal-made condenser microphones, and with actually any kind of measurement microphone. So this version opens up the measurement possibilities to any measurement microphone you can have. You can even load the calibration file if you have a calibrated microphone. So that's bring the precision of the system close to what you get with this microphone, even with any commercial RTA or measurement microphone.
And is it an Omni mic or is it a stereo mic? Just curious about the microphone itself.
It's an Omni mic. It's an Omni mic because you need to have all the contribution from the room.
The reflections,
so you need yeah. And also you don't want the proximity effect of cardioid microphones. So that's why it's an Omni.
Another question. So could you use that mic for recording if you wanted? Would it be useful for anything? I mean, just out of curiosity.
I have to say, with the older microphones that we were selling with the original ARC versions, the reply to this question could have been yes. It was a good microphone. This one is better for measurement, but it's not suitable for recording because the frequency response should be corrected. So unless
I see what you mean. Yeah. I understand. So the other part of this is the software components, which have there been some changes with that as well?
Yes, I'm showing here now the first of the two software components that makes the system. The first of the two is the measurement application. So this is a standalone application that you are using to measure the room. Ideally, you will use this only once, or at least you will need to remeasure the room if you change anything in the furniture, if you change the speakers, if you change the arrangement of the room. So this is a tool that you use for the first time. We put a lot of effort in this application to make the measurement process simpler. We know that users using previous versions of ARC, they were kind of scared with the measurement process, and so they were very precise in placing the microphone in specific position, even taking notes on the floor, putting tape, marking tape on the floor.
Right.
We wanted to go over this and provide a simpler experience for the measurement. Also because we think that users should experiment measuring the room more than one time in different positions with different speakers, if they use more than one pair of speakers. So that's why the measurement is so streamlined. You see that you can select the previous version of the microphones of ARC, or this is the new one, the MEMS one. And as I was saying before, you can select any generic measurement microphone, and even loading the calibration here.
Yeah.
So once the microphone is selected, you go on. You have, of course, your typical audio setup settings for the audio interface and where the microphone is connected. And then this is one of the first new things of ARC 3, because you see that you can select different kind of rooms and listening setups, we could say. Going from the project studio to a bigger board-equipped studio, wider listening area, and coach in the studio together with the main listening position, and even an home theater.
Right.
So this is because the algorithm is taking into account the kind of space that you are working in, and it's weighting the various measurements and the various issues that is detecting in the measurements differently, depending on how close you are to speakers and how wide the listening is. Yeah.
So
going on.
I've just one more question. What?
Yeah, sure.
Can you use this for? I mean, say venues, larger rooms where maybe there's an audience and a large PA system. Would it be applicable for that kind of thing? I mean, I know you don't have that listed there, but could you use it for that?
You can use it for that. There is a limit in the latency, so the system must be not too far from the microphone.
Right.
But the limit that we have now is supporting even very big spaces. So,
interesting.
yeah, it's not. I mean, it's not the main goal of the application.
No, I understand. Yeah.
Because but it works. It works, and it gives pretty much surprising results.
Right.
Yeah. So going on, you see that the user is guided through correct microphone positioning,
right. So
explaining the basics.
It's very clear.
Yeah, and then you have a test for the levels here.
The sweep.
Yeah. This is for setting the level of the microphone preamp where the microphone is connected. And then once you have this done and the levels are right, you go to the measurement. You see here, you can see we have the 3 layers. So that's the news. The DSP system is
right. So it's more or less the height of the head, really. That's what you're that's what you're going for there, right?
Yes, it's 3 layers spaced about 15 centimeters one each other, centered at the ear level, and one is above and one is below.
Yeah.
This helps a lot in identifying what to keep from the room measurements and what to remove.
Right.
And actually helps a lot in providing a transparent result. Once the user gets here, you see now I have selected a wider area. You see all these points.
Right.
They get measured this way. So this is one channel, and then we have the other channel.
So you do left and right separately, right? Okay.
Right.
And then you just go through all of those, and that
you go through all of those.
Yeah, all of those, right? Yeah.
Yeah. I cannot go ahead now because I should finish them all, but it's taking too long for the video. Normally it's taking between 7 and 10 minutes to do the complete measurement process. So it's quite fast. Once you get it done, you just name the measurement session the way you want it to be named, and then the measurement set appears in the plugin. Let me switch here. Okay.
Right. Okay.
So this is the plugin. This is the second component of the system. It's a multi-platform audio unit VST and AAX plugin, sorry, that you open in Pro Tools, where you can load the measurements that you saved with the analysis tool. So you see now here I have loaded these speakers here in this room. The green line, the green curves that you see is the original response of the system in this room. You see there is a huge dip hole here. Yes, that's terrible, but it's good. It's this way because it's clear what it does. For example, if you take only left,
that's got a huge hole. Right, I see.
Yeah, this is the corrected version. It can be seen that it's not making it totally flat. It's keeping a little bit of the original
character. Yeah.
Yeah, just a little bit. And this is part of the multi-layer measurement. If this was taken only on a single plane or on a few spots, it would probably have been flat, but it would have sounded less natural.
Okay.
So that works pretty well because it's really taking away what's bad and it's without making it sounding artificial,
so how far can it go? I mean, how bad a room does it have to be before there's no hope?
Oh, well, this is pretty bad. The one that we are seeing here is pretty bad. Because this all I think was about 15 dBs.
Wow.
So,
okay.
And also on the right channel, it was similar. Yeah. So it will not make a set of multimedia speaker to sound like a PMC couple of monitors. This will not happen. But I think for any standard equipped project studio, from the project studio to the top control room, anything can be addressed, because it's really working very well within the limits of the speakers. We cannot extend up to 20 hertz a small speaker. This is
no.
this
Okay.
is not.
Yeah. So the other thing I was going to ask is, this works mostly on it's on the frequency curve. It can't really affect anything with time domain. So if you've got too much flutter echo or there's a reverb to the room, it won't correct any of that stuff. It's just the frequency responses, right?
It's working both on both on frequency and time domain. It's actually addressing also phase issues, but it's not taking away the reverb. That's correct.
Okay, right. Okay, cool.
No. In fact, one of the big things about the new version of the software is that you have two phase modes here. One is natural and one is linear. The difference is that in natural mode, the system is also addressing the phase response of the two channels. Typically in untreated rooms, it's common to have phase issues between left and right channels at certain frequency spots, especially in the low end, on the bass part. Because maybe you can have a window on one side or a door on the other side. It's not symmetrical. So when it's on natural, the system is addressing the phase response of the two channels, and it's making them more similar one each other. So this is
that would presumably tighten up the low end focus, and also further up the frequency would kind of address the stereo imaging a little better. Yeah.
Exactly, is improving the ghost center image a lot for the low frequency, which is typically a very bad problem of untreated room. And instead, in linear mode, the system is respecting the original phase response of the system. So of the system in the room. Right. So sometimes when you are in very high quality rooms with very high quality speakers, you don't want to touch the phase. And this is the case where this is preferable. Instead, natural is working very well in average rooms where you need some kind of addressing of the phase response. Another very interesting feature of the new plugin is the virtual monitoring. You see, we have a list of traditionally common check speakers when you are mixing. So, for example, these are of course, you can recognize them from the response. It's the
NS10.
NS10, correct. This is an LCD TV.
Okay, interesting. So you can create monitoring checking systems as well. Exactly. So it flips the other way and emulates. Interesting.
Exactly. And this only works before you are able to make the system linear before. I mean, once you get a linear performance from the system, then you can mimic other references. So this is a laptop, and this is an iPhone. So
wow, that must be weird, particularly if you've got big monitors and you get an iPhone response coming out of them. Interesting.
It sounds very small, yeah. It's very useful, yes. And additional options that you have with Arc version 3 are here in the edit page, where you can define the range boundaries of the correction. So let's say these speakers in this room must be corrected, but you like the timbre they have, you like the mid and high frequencies voice they have, you just limit the correction up to here, and this makes the system to behave exactly as it was before the correction from this frequency on.
Oh, interesting.
And this is especially useful when someone gets very used to the speakers they are using, and they don't want actually to change the voice of the speakers. They just want to fix the anomalies that there are in the room because of low mids and low frequencies. That's
an interesting idea. Okay, cool.
Yeah, even if most of the time you will want everything to be addressed, but sometimes not.
And can you save those as presets as well? So would that be something, or is that something you have to do after you've saved the preset?
You have to do it in the plugin right here.
Right.
Yeah. Also because this way you can change it anytime you want. It's also on the low frequencies, it can be controlled at the range where it's trying to go on the low end. For example, if the system is pushing too much at 30 Hz, for example, you can just limit it here and avoiding this extra push.
Okay.
You can also tweak the response to your taste. Let's say once the system is corrected, you, for some reason, are finding it as slightly light on the low end. You just can you can just give a couple of dBs.
So you give it a tilt or a right, okay.
Yeah, and the good thing is that this is not an equalizer. You see that it's taking some time to apply the change, because it's not an equalizer that is overimposed on the correction, so creating phase problems and so on. This is the actual ARC3 filter that is recalculated to match this new target curve in place of the flat one.
Wow, okay.
Yeah.
Very clever stuff.
Thank you.
So, this, as you say, this, by the time people have watched this video, this will be out.
Exactly.
And you typically put this on your master bus or your monitor bus, presumably, because you don't want to necessarily bounce your mix through this. You would want to only monitor through it, right?
Right. That's the reason why we have a very precise and feature-filled metering session here, because you can understand this is very useful, because this plugin is actually destroying your levels on the master bus. So you cannot rely anymore on the metering of your DAW for the master bus, because this is applying strong cut and boost to the frequency ranges. So you need an additional meter inside here to still being able to precisely monitor the level of your program. That's why we have added this meter that is selectable between pre and post, but I would say it's more useful in pre, that is selectable between peak, RMS, and loudness and dynamic range.
Right.
So you are putting this on the master bus. You cannot see your levels anymore, but thanks to this integrated high-quality metering section here that is taken from the T-Rex 5 metering, you are still able to properly monitor your levels. As you can see, we have also added, I think, this very nice feature here that is a real-time analyzer. One might say, I don't need an analyzer in this plugin, because this plugin is actually going to be set up and closed all the time. But actually, if I remove the corrected responses here and only look at how the system was performing before the correction was made, it's very interesting when you play music to see what frequencies you were missing from the program.
Okay, right.
Yes, or you were listening them overboosted. Not in this room. This room is mainly cutting stuff, but it's very, I think, interesting and
so it's like an extra analysis tool, I suppose. Yeah.
Yes, to analyze your room, because now you can understand which bass notes you are missing, for example, right. when the system is not corrected. So this is an additional tool to see what has been done to the room. Yes.
Excellent.
Other things are that, of course, the target curves can be saved to presets, and they can be recalled here from the play menu.
Right. Right. Well, thank you, David. That's very comprehensive. So, like we say, this is available now. What does it cost? And they're presumably cross grades. And if you've already got a mic, what are those details?
Yes. Also consider that the system can be used, as we said before, with any measurement mic now. So it's a pretty interesting news. Also this one.
Great, David. Thank you very much. Thank you very much for showing us that. And,
thank you, Nick. Thank you, and of course, thank you to Sonicstate for this opportunity in this difficult time.
You're welcome.
Say, thank you. I really would like to wish everybody to stay safe and and get a lot of joy from music in this period, making music the way that we like to do.
Well said. Thank you very much.